Welcome and thank you for joining. My name is Ashley Mondello and I'm the Vice President of Operations at Language Scientific. Today we're going to be discussing how AI technology can revolutionize multimedia localization. This presentation will cover the challenges, the opportunities, and AI-driven solutions for optimizing localization workflows. The research discussed in this presentation was funded by Language Scientific. Language Scientific's technology experts combined force with academic and industry leaders in the machine translation space to produce this case study. The Big Multimedia Localization Challenge. With the rise of video as a key medium for information and education, the demand for localized content has surged. This presents significant opportunities for LSP providers to grow their revenue by optimizing multimedia localization. However, challenges such as high costs, lengthy timelines, and sourcing difficulties hinder LSP's ability to meet client expectations for faster and more cost-effective solutions. Leveraging AI technology to shorten turnaround times and reduce spend is becoming necessary. However, LSPs may not be prepared to adopt workflows and tools used by media service providers, and choosing tools that most effectively optimize their specific workflow can be challenging due to the plethora of options that are available. Our research focuses on evaluating AI-driven solutions to enhance efficiency and reduce costs in workflows that rely heavily on human intervention, steps such as transcription, translation, voiceover, and subtitling. The goal of our research was to provide guidance for LSPs on how to select the best AI tools for their workflows. We examined 3 categories of AI tools: open source solutions, commercial AI solutions, and specialized video localization platforms. This case study specifically looks at tools for automatic transcription, machine translation, synthetic voice generation, and automatic subtitling, with a primary focus on 2 high-demand language pairs: English into Chinese Simplified and English into Spanish Latin America. We evaluate each tool based on the ease of use, cost, language support, and quality. First, let's take a look at the traditional subtitling workflow, which, as you can see, involves numerous steps and handoffs. For our case study, we used 11 minutes and 8 seconds of video content to localize into Chinese Simplified and Spanish for Latin America. This diagram depicts the workflow steps and the time associated with each step to localize the video content for each language using the traditional subtitling method. For a little over 11 minutes of video content, the process takes 19 hours of labor per language, which illustrates just how tedious and time-consuming the localization process can be. This workflow included transcription, QA, translation, editing, and 2 rounds of video QA and engineering, with each step requiring specialized human resources, which adds to the time and cost. Additionally, every arrow in the diagram represents a handoff that required PM human intervention. As you can see from the diagram here, the traditional voiceover workflow is even more time-consuming, taking about 24 hours per language for the same video. This complex process includes transcription, QA, translation, editing, voice recording, and multiple rounds of video QA and engineering. The extensive time management and high costs are a major drawback of these traditional workflows. The question for us became, how do you reduce the number of workflow steps and handoffs to reduce cost and turnaround time? The traditional multimedia workflows present a number of challenges for LSPs. First, managing resources and coordinating the different stages of the workflow requires meticulous planning and time management, which results in high PM costs. Second, in voiceover workflows, sourcing high-quality talent can be a struggle. LSPs must often weigh the trade-offs of hiring an independent voice talent versus using a voice talent agency. Independent voice talent services usually come at a lower cost, but are often resources that don't have professional studio setups, which can result in a lower quality output. On the other hand, voice talent agencies are equipped with professional studios and sound engineers, which produce high quality outputs but are generally more costly. Next, labor costs for high-skilled resources such as video engineers can make it difficult to keep costs low. And finally, due to the sequential and manual nature of the task, the localization process is time-consuming and involves multiple handoffs. Meeting tight deadlines becomes challenging, especially when handling large volumes of content or multiple language pairs at a given time. To evaluate productivity gains using AI in the traditional multimedia localization processes, we chose to replace specific steps in the traditional workflows with AI tools. without the integration of workflow automation. To maintain comparable quality to traditional workflow outputs, we decided to keep all QA steps in the workflow human-driven. The primary goal was to assess the productivity impact of low-level AI integration for LSPs that are at the beginning of their AI adoption journey. For the subtitling workflow, we replaced transcription with Amazon Transcribe, translation with Amazon Translate, and video engineering with Amazon's Pipeline. The introduction of these 3 AI tools resulted in an 11-hour time savings in comparison to traditional workflow. We followed a similar approach for voiceover localization workflow by replacing transcription with Amazon Transcribe, translation with Amazon Translate, voiceover recording with Amazon Polly for Spanish, and Google Text-to-Speech for Chinese. The utilization of AI voice generation resulted in the removal of voiceover QA, voiceover fixes, and voiceover QA verification steps, because once synthetic voice is generated, there's little to no editing that can be done to the recording. Amazon Polly and Google Text-to-Speech do not allow for tweaks to term pronunciation, voice inflection, or any edits that you would normally be able to make with a human-driven voice recording. While this resulted in significant reduction to the overall timeline, it also limits the ability to rectify potential speech issues. Overall, the case study revealed that AI-assisted workflows can reduce the required labor hours by over 50% in both subtitling and voiceover processes. The quality and availability of AI tools, however, vary dependent on language pair, which underscores the importance of selecting appropriate tools based on the project requirements. As seen by our case study results, the integration of AI technology into traditional multimedia localization workflows offers significant advantages in terms of efficiency and cost reduction. However, choosing AI tools that most effectively optimize an LSP's unique requirements and processes can be overwhelming. In the following slides, we assess AI solutions that offer efficiency and cost reduction in a traditionally human-driven workflow of transcription, translation, voiceover, and subtitling, with the goal of guiding LSPs in selecting tools that best work for their scenarios. As previously mentioned, we evaluated the selected AI solutions based on 4 criteria: ease of use, cost, language coverage, and quality. Since ease of use is different depending on the technical skills of the person operating the tool, we assessed ease of use from a project manager perspective as well as a developer perspective. 2 project managers and 2 developers at LS assessed the usability of the tools based on a low, medium to high scale. When looking at cost, we assessed also on a low, medium, high scale, with low pricing being most suitable for LSPs with up to 50% of their revenue being comprised by multimedia. Medium pricing being most suitable for LSPs with between 50 and 75% of their revenue comprised of multimedia, and high pricing being most suitable for LSPs with over 75% of their revenue comprised of multimedia. For language coverage, we looked at the number of languages supported as well as the dialects and regional varieties. For quality, the evaluation was performed using automatic metrics when available, and when possible using human ratings. We investigated 3 categories of AI solutions for video localization workflows. First, open source tools. Second, commercial AI services and APIs. And third, dedicated video localization platforms. Our evaluation covered tools for automatic transcription with timestamp prediction, machine translation, synthetic voice, and automatic subtitling. For transcription, the tools we compared are Whisper, Amazon Transcribe, and MateSub. We only tested tools with output timestamps since these are vital for synchronization in both subtitling and voiceover. Whisper has the lowest cost since it only requires a computer with some computational power and no subscription. Amazon comes next with a pay-as-you-go pricing model, while MateSub requires a subscription with dedicated number of minutes available per month. In terms of ease of use, Whisper scored high with developers but low with project management. Even though it's straightforward to use with people with programming skills, most PMs may not be familiar with operating a computer terminal. MateSub and Amazon offer friendly user interfaces, and thus their ease of use is rated higher. Transcription was evaluated using word error rate metric. Whisper produced the lowest word error rate metric on LS projects, followed by MateSub and Amazon. However, MateSub's timed transcription differs from Amazon and Whisper in terms of conformity to length and reading speed. Because MateSub is a subtitling tool, it generates shorter segments. These segments conform 100% to the standard subtitling length constraint of 42 characters per length, while the mean length for Amazon and Whisper was 57 and 49 respectively. To conclude, the time transcription of MateSub are more suitable for subtitling projects, while Amazon and Whisper generate longer segments, which make them ideal for voiceover projects, which need to maintain longer units to improve on synthetic voice outputs. Translation for transcribed video content poses challenges compared to text translation because of the oral style and partial inputs. For ease and cost, Amazon and Google scored similarly in terms of ease of use, since they are both well integrated with CAT tools and offer APIs and UI to obtain translations. Both Google and Amazon's pay-per-use models are comparable in cost and lowest among the evaluated tools. ChatGPT has a lower ease of use for both developers and project managers and a higher cost. Translation quality was evaluated using Comment. For content commonly translated in LS multimedia projects, all three tools performed well, with Google performing the highest, followed by ChatGPT and then Amazon. While all three tools produce similar quality, our evaluation determined that currently Google and Amazon are the most suitable options for LSPs based on their high ease of use and their low pricing compared to ChatGPT. In terms of language coverage, while all three tools offer a variety of languages, and most providers are expanding their language support for MT, language availability is still highest for Google. For subtitling, we determined that Amazon's pay-per-use model is more cost-effective than the subscription-based model of MateSub. For ease of use in Amazon, subtitles are generated in a multi-step process, which involves uploading and downloading input and output files via a user interface. This process is comparably more cumbersome than MateSub for project managers. In MateSub, the video is uploaded to the platform and the subtitling guidelines and target language are selected, making it easy to use by PMs who are familiar with the requirements of subtitling. For subtitling quality, synchronization and readability was evaluated using SubER. SubER is an edit-based metric which considers the edits in text, timestamps, and segmentation. We also reported on subtitle conformity to the formal constraint of length and the reading speed. In terms of subtitling quality on LS projects, Amazon had a better SubER than MateSub for both Chinese and Spanish. However, as mentioned in the transcription evaluation, Amazon had a low CPL. In terms of language coverage, both tools scored similarly as they both have an equal variety of languages available. For voice generation, Google and Amazon have a medium to low ease of use because voice generation is performed through an API where text must be copy and pasted. Since voiceover has to be synchronized with the video, the synthetic voice must be generated sentence by sentence and not as a large chunk of text, which can be time-consuming for the project manager. Additionally, Google has a demanding setup process for the API because of the modular structure of Google Cloud. But once set up, it was relatively easy to use, hence the medium to low rating. Both Google and Amazon require developer expertise to adjust cadence of speech. Speechify allows for uploading timed SRT files, which performs the synchronization automatically. Speechify also has integrated voice editing, which allows the PM to adjust the speed and synchronization of generated voice samples. For assessment of quality, we collected human ratings from 5 native speakers on the naturalness and clarity of the generated speech. Google scored higher for Spanish for the male voice, while Speechify scored higher for the female. For Chinese, all participants rated Speechify voices with the highest score in terms of naturalness and clarity, showing that for some languages and project types, synthetic voice may be a feasible alternative. Language coverage is an issue for VoiceOver for both Google and Amazon. They support a limited number of languages and varieties. In addition, very few of the models have both male and female voices, and some language and gender voice options are only available using lower quality models. Speechify offered the widest variety of voice options in both gender and language coverage. To conclude, for voiceover projects, language and model type available is the most decisive factor when selecting a provider. Speechify has high quality of synthetic voices and an integrated editor, while Amazon and Google can be good for occasional projects but require video synchronization as an additional step. When deciding which AI tools to integrate into their workflows, LSPs should follow a systematic approach that takes into account the aspects presented as they relate to their own production workflows. Our exploration of AI solutions for multimedia projects revealed that commercial AI services, which offer all-in-one solutions by the same provider and require medium technical skills, can be a good starting point in integrating AI and most suitable for low to medium project volumes. For high volumes, open source tools such as Whisper can prove worthy investments, but require staff with technical skills as well as equipment with some computational power. Tailored solutions also suit high volumes. Multimedia platforms such as MateSub for subtitling and Speechify for voiceover offer high-quality, low management effort. On the other hand, the cost is slightly higher, and linguists need to be trained on how to use the tools. When selecting AI tools, LSP should also assess whether their multimedia projects are suitable for AI integration. The efficiency gained from AI in multimedia projects can be significantly influenced by the complexity of the source material. For example, videos featuring multiple speakers, extensive on-screen text, or embedded PowerPoint presentations present synchronization challenges when processed with AI tools. Furthermore, target audience of these videos must be taken into account, particularly with voiceover projects. Despite considerable advancements in synthetic voice technology, AI-generated voices remain distinguishable from human voices. LSPs must carefully evaluate how the intended audience might react to synthetic voice when considering AI's role in their projects. Thank you so much for your time today, and I look forward to answering questions.